All right. Check, check. Check Niasi. Check me out. All right. Algebra 3. Quarterfinal. 1 through 20. Review. Part 1. All right. First most missed question. Number 4. Number 4, we got y minus x equals 3. We got x squared plus y squared equals 17. First thing that we want to do is identify what kinds of graphs we are working with. Okay, we have a circle here and a what on top? Nope, a line. So as I look at the graph, I got a circle, line. Okay, I should have 2 points of intersection. Okay, first step with this is make my line solve for y. Okay, so y equals x plus 3. Okay, now that I know what y equals, I can substitute that in. So I get x squared plus x plus 3 squared equals 17. Okay, how did we do to that point? Did we get that right? Did we miss that? How did we start? Did we start the right way? Okay, so x plus 3 needs to be FOILed. Okay, so I'm going to do a lot of this verbally. Tell me if I need to slow down or if I need to go back and draw it. Okay, x times x is x squared. X times 3 is 3x. 3 times x is 3x. And 3 times 3 is 9. Do we understand that? Okay. Figured that's probably one of the things that would go wrong is that students wouldn't FOIL it. Combine like terms, so I have 2x squared plus 6x plus 9 equals 17. Subtract 17 in order to get it into a quadratic. 2x squared plus 6x, what, minus 8? Equals 0. All right, at this point, to avoid just trying to work aimlessly, I'm going to plug this into the quadratic formula. Okay, so I'm going to get negative 6 plus or minus the square root of 6 squared minus 4 times 2 times negative 8 all over 2 times 2. Does that work for you guys? Okay. Negative 6 plus or minus over 4. Okay, because those are the easy things to do. Looks like I have 36. I've got 2 negatives over on the other side, so I should get something like 36 plus. Looks like that would be, what, negative 8 times negative 8. So I should get 36 plus 64, right? Okay. Fortunately for us, 36 plus 64 comes out to a nice, neat, even 100, right? So I got negative 6 plus or minus the square root of 100 divided by 4. Square root of 100 simplifies, so negative 6 plus or minus 10 divided by 4. Okay, so I have 2 options for x at this point. Okay, I have x equals 2 different things. So negative 6 plus 10. What's negative 6 plus 10? What's 4 divided by 4? 1. So x can be 1, or negative 6 minus 10, which is negative 16. Negative 16 divided by 4, negative 4. So my 2 options for x are 1 and negative 4. Now, we're not done yet because we need the y solutions. So that means we come back up here, okay, and we can actually just plug those into this, okay, to solve for y. So we can do y equals, what did we say? We had 1, right? 1 plus 3 is 4. So when I have 1 for an x value, I get 4 for a y value, right? Yes? Okay. And what, the other one was what, negative 4? Negative 4. So if I plug in negative 4 plus 3, negative 1.
Okay, I have a question.
Okay, what's your question?
Got lost at x equals negative 4.
X equals negative 4. So let's come back down here. All right. So notice how this negative 6 has a plus or minus 10. Okay. So did you understand how we got negative 4? Is that where our question is? How did you get negative 4? What's negative 6 minus 10? It's negative 16. But I'm going to take negative 16 and divide it by 4. Yes, because it's plus or minus. So I have to do the plus and solve, and then I have to do the minus and solve. So that's how I get 1 whenever I add, and I get negative 4 when I subtract. Okay? All right, and then, but that's not my final answer because then I have to come back up, plug those things in, and get a set of coordinates. Okay? So there's a lot going on there, so I can understand why that's our most missed question. Okay? All right, next up is number 5. Okay, so we're dividing x cubed plus 4x squared plus 10 by x plus 3. Okay, so there's 2 ways to do this. There's long division, and then there's synthetic division. Synthetic division is by far the easiest, but you have to know what you're doing. This is something that you should have learned in Algebra 2. Okay, I can use synthetic division anytime I'm dividing by something that can be solved. Okay, x plus 3 can be solved because we can take x plus 3 equals 0 and solve and replace x with negative 3. We can replace x with negative 3. Does that make sense? You can't solve it if it's squared. So if it's a quadratic, you can't solve that. So it's got to be x plus or minus a number in order for you to use synthetic division. Okay? Okay. So using synthetic division is going to be way easier. I can show you both ways. When we use synthetic division, we take the coefficients for these values up here. And so I have 1, 4, and 10. Okay? What's that? Oh, yes, you are right. I would put a 0 for x because we have to have all of our spots. Okay? 0 and 10. Good catch. Okay? So now we're going to divide by negative 3. And we bring our 1 down here. Okay, so remembering what to do at this point is the important part. First, so whenever I'm at this point, I multiply. Okay, so it's negative 3 times 1 is negative 3. So I multiply on the outside, I add on the inside. So 4 plus negative 3 is 1. Then I multiply. So I get negative 3 again. And then I add 0 plus negative 3, negative 3. Negative 3 times negative 3 is 9. Okay, 10 plus 9 is 19. Okay, this is my remainder. Okay, so what we do with these numbers is notice how this was an x cubed up here. And so when we divide, we take this coefficient, which is just 1, and then we take what we were dividing by, that exponent, and we make it 1 less. So it's x squared instead of x cubed. Okay, does that make sense? Okay. Plus, leading coefficient is 1 with just x, minus 3, okay, with no x because we're going 2, 1, 0, okay, plus our remainder over our divisor, which our original divisor was x plus 3. So that should be my answer. Is that what you got in the answer key? Pretty simple, pretty simple. Do you need to see it the long division way? No, I wouldn't. It's way more complicated.
This was like one of the things that I struggled the most on.
All right, but does it?
Oh, no, I didn't know.
Okay. That's good. You've learned. Okay. All right. We're ready to move on past this? Okay. All right. Number 8. Okay, let's see. Simplify. 3i squared minus 4i cubed minus 2i to the 4th all over 2 plus radical negative 9 plus 4i. Okay, so I'm going to focus on just the numerator for now. I'm going to simplify the numerator as much as I can. All right, so I've got 3, and I'm going to replace that with negative 1 minus 4 times negative 1i. Okay, does that make sense?
Yeah.
Okay, I can slow down. Okay,
I think we has 3 eyes, but it just shows it as.
well, because there is 3 i's, 2 of those i's become a negative 1, which leaves 1 I left over. Okay? Now, I to the 4th is always 1. Okay, because it's negative 1 times negative 1. Does that make sense? Okay? So 3 times negative 1 is negative 3. Negative 4 times negative 1 is positive 4i. And negative 2 times 1 is negative 2. Okay, we can combine like terms. We would get negative 5 plus 4i. And that's my numerator. Okay? Okay, that's what's up. That's what's up. Okay, now this next part. Okay, we're coming down to the denominator. We have 2 plus, okay, we're going to take out the I. And so that would give us radical 9. Radical 9 is the same thing as 3. So we've got 2 plus 3i plus 4i. Okay, combined like terms, I get 2 plus 7i. Biggest mistake here is to assume that this is the end of the question. It's negative 5 plus 4i over 2 plus 7i. Okay, because we've seen questions like this, right? That start out that way, right? Negative 5 plus 4i over 2 plus 7i. We've seen questions that started there. What did I have to do to solve it? Multiply by the conjugate. And that's exactly what we do here. 2 minus 7i over 2 minus 7i. Okay, so yeah, it's a long question to solve because now we have to FOIL the numerator and the denominator. Okay. Negative 5 times 2 is negative 10. Negative 5 times negative 7i is positive 35i. 4i times 2 is positive 8i. And 4i times negative 7i is going to be negative 28i squared. All right, so negative 28i squared. Okay, so hold on before we're all done. What's that I squared become? Negative 1. It's negative 1. It's negative 1. I squared is negative 1. Okay, so I'm taking negative 28 times negative 1, which is going to mean that this is becoming positive 28. Combine my like terms here. I've got 35i and 8i, which is what? I should know. It should be what? 45i? No, that's not right. 43i. 43i. 43i, and I've got negative 10. Okay, so I've got negative 10 and positive 28, so it's going to be what? 18. 18 plus 43i. That's my numerator. Okay? It doesn't matter if 43i is in front, but you need to be in the habit of putting a constant and then my imaginary. Okay? It's just a good habit to get into because it will matter later on down the road. Okay? All right. So we hold on to this guy, and now we work with our denominator. Okay? 2 times 2 is 4. Notice that they are some difference, so I just need to do 7i times negative 7i, which would normally be negative 49i squared, which is -1. So it's really 4 plus 49, which is 53. Okay, so now my answer is 18 plus 43i over 53. It's just that easy, folks. It's just that easy. Okay? Okay. Okay. All right. 10. I wish I could get this to go away. All right, 10. Okay. N over, these are so much fun. N plus N over X plus N over Y. All right, so this is a matter of knowing how to add and divide fractions and rewrite over and over and over again until you've got it totally simplified, okay, which is frustrating, okay, and time consuming. So you start from the bottom and work your way to the top, okay, like that old TV show song, right? Started at the bottom, now we're here, okay, so.
Yeah, that's a song.
That's a sample from an old TV show. So no, Drake didn't write that. Look it up. We started from the bottom, now we're here. He didn't write that. It's like before me.
What's the show? Oh, never mind.
Gosh, it would have been. I'm trying. I think wasn't the Sanderson. Anyway, all right. So let's get back to this. So the first thing I want to deal with is x plus n over y. X plus n over y. That's really x over 1 plus n over y, right? Anything we're adding something to a fraction, we're really adding two fractions. So step 1 is to get a common denominator, right, between x over 1 plus n over y by multiplying this by y over y, correct? So I get xy plus n over y as the simplified form of that, okay? Does that make sense? Okay. So you're going to hear me say that a lot. All right, so now I'm going to rewrite that whole thing again. Okay, so I got n over n plus n over xy plus n over y. This right here being the fraction that we just wrote, okay, which means the next step is this part right here. Okay, I have n divided by a fraction. Okay, can I divide by a fraction? The short answer is no. Cannot divide by a fraction. Guys, we're in Algebra 3, we know this. We cannot divide by fractions, but we have an alternative. What's the alternative? Multiply by the reciprocal. Multiply by the reciprocal. So I'm going to, if I'm taking n divided by, that's effectively n over 1 divided by, or multiplied by the reciprocal. What is the reciprocal? Y over xy plus n. Okay, which comes out to what? Okay. All right, so n times y is ny. 1 times xy plus n is simply xy plus n. Yes, this is the n that goes here. Okay, n divided by xy plus n over y. This is the numerator to this, not the denominator to that. Okay? Does that make sense? You could technically probably read it that way if you're taking n over xy plus n divided by y. Then I would have to multiply by the reciprocal still, and I would get the same thing. Okay, so I read it as n divided by xy plus n divided by y. Well, you're going to have, yes, you will have to simplify at the end. So if there is a term in every, if there's a common thing in every term, then we will factor that out. All right, this is taking Too long. Okay. So we need to take that answer and plug it in. Okay, and so rewrite n over n plus our new fraction, which is ny over xy plus n. Okay, so now this is the new problem. Okay, what am I going to write this in right here over? Okay, so step 3, n over 1 plus ny over xy plus n. What do I have to have in order to add fractions? What is the common denominator? xy plus n. So this is probably the hardest step of them because there's the most to multiply. Okay, so we have to distribute in this case, right? We already know our common denominator is going to be xy plus n, correct? Okay, so I don't have to worry about that. But I do have to get, all this. We know that we're going to have plus ny over here. So I'm going to take xy times n, which is what? nxy, okay, or nyx or whatever, plus what? Plus n squared, okay, plus ny over xy plus n. So this, okay, is the solution. So we replace that, okay, we're going to plug that in. And now we rewrite it again, okay. Let me scroll a little bit. Okay, so now we have n divided by that fraction, nxy plus n squared plus ny divided by xy plus n. Okay, again, this is the fraction we are dividing by. Okay, so it's n over 1 divided by nxy plus n squared plus ny divided by xy plus n. So we come over here, we write that as n over 1, but I can't divide by a fraction, so what do? Multiply by the reciprocal. So over here, okay, in the new numerator, I have xy plus n. Right? Okay? Down here, I have nxy plus n squared plus ny. I'm going to have to distribute n in the numerator to every term in the other numerator. So I have, up here, I have nxy plus n squared all over nxy plus n squared plus ny. And so to answer the question that was asked earlier, do we have to simplify the final answer? Yes. What exists in every single term? An n. Okay? So we're going to take an n out of everything, and I'm going to get xy plus n over xy plus n plus y. Okay? Sorry, my n's look a little like h's. Okay, that should be the answer. What was this, number 10? Hold on. Okay. Can you turn your mic off so that I'm not echo. Yes, Eric? Can you cancel out the xy plus n's? No. No. Because it's not xy plus n over xy plus n, which would cancel. But no, their final answer leaves it like that. Okay? All right. I can only do so much here. Number 3. Okay, we only have so much time. 3. Two-column proof. How many of you are going to do the two-column proof? Okay, all right, so let's do it. All right. Statement, reason. Okay. L O Q N M P. Okay, so start off with what they give you. Okay, so the answer is our two-column proof, but I put the picture over there so I can add to it the stuff that they give me. They tell me that LM is parallel to OP. Okay, given. Okay, so now as they give me that information, I can fill it in. LM is parallel to OP. Okay, they also tell me that MN is parallel to PQ. Given. All right, so we have MN, PQ. Now this is what is hard for you to see. So I'm going to go ahead and write, I'm going to draw this in. This is a geometry principle. Okay, what I have there is two parallel lines cut by a transversal. Do we see that now? All right, so this angle and this angle are congruent because two parallel lines cut by a transversal have corresponding angles congruent. Okay, so I can say that angle L is congruent to angle, and I can't just say O there. I don't think I can just say O. Because O can be a part of other things. It could be like POL. So I have to say angle POQ. Okay, and that is what we call the corresponding angles postulate. Okay? Because it's the only angle that can be made with that letter. If you want to be more specific, then by all means be more specific and say PLO or PLQ or PLN for that matter. It doesn't when I can just say angle L. Okay. All right, the same thing happens over here with these, is that I get corresponding angles again. So I can say angle N is congruent to angle PQO through the same thing, okay? Now you should write it out. I can get away with it because I'm the teacher. Okay? It's a double standard, I know, but I put in the hard work. Okay, got the degrees. All right, so we just want, I mean, what is it that we're trying to find? We're just trying to say that these two triangles are similar, right? Okay, do I have enough information? Yeah, I do. I can say that triangle LMN is similar to triangle OPQ through the angle similarity postulate. Because I only need two angles to be congruent to two angles. Okay? That's it. But you have to be able to see two parallel lines cut by a transversal, and you have to know that they're corresponding angles, right? All right, so that was number 3. You need number 9. Yins varies directly as yangs. Okay, and we would need a K up there. And inversely as jades squared. Does this make sense? Okay, I'm going to run out of time. I'm going to do as much as I can. All right, so we have to set up what they're saying first. K is always going to go in the numerator. Okay? All right, and then they're going to give you some information. There's 15 yins, 90 yangs, and 6 jades. Okay, so 15 equals 90K over 36. Okay, multiply by 36. You're going to have to help me out here on the math. What's 15 times 36? 540 equals 90K. Divide by 90. Probably get, what, 6? 60? Is it 60 or 6? Okay. Okay, so K equals 6. Okay, so then they're going to ask for you to plug 6 in to solve for what I'm guessing is yins. Yes? Not with 1 minute left till the bell rings. Okay, so I ask you to solve for your yins if there are 64. So that's going to be 64 times 6 because we have to put the K back in. 4 squared jades. Help me finish this out with 64 times 6. 384. What's 384 divided by 16? 24. Okay, your final answer should be 24. All right, I'm going to have to stop there. What was this, question number 9? Okay, I'll try to finish up on my own.
Let's say